Right, so in this video I'm going to have a quick look at increasing and decreasing functions. We've got these two conditions for it. So the first one, function is strictly increasing if x2 greater than x1 implies f of x2 is greater than f of x1. What this means is that if, well, we assume that x2 is to the right of x1, okay? That's what it's saying with x2 being greater than x1, but it implies that the y value at x2 is greater than the y value at x1. So that means that as going from left to right, the function is increasing, it's going up in value. And likewise, it's strictly decreasing if when x2 is greater than x1, so again going from left to right, implies that the y value at the second point is lower than the y value at the first point. And so that means actually that this idea of strictly increasing or decreasing does actually include turning points, as they are going to be higher or lower than other points that are around them. And so what that means is that when we actually write out a domain for where something is strictly increasing or decreasing, we can actually use round or square brackets, and it doesn't actually make a difference to the answer. So if we have a quick look at this graph just here, what I can say then is that it is strictly decreasing. Oops. That's interesting. Anyway, so strictly, let me just fix that up because that was really shocking. Okay, strictly decreasing for x is an element of, and I'm going to use the square brackets first, so I can say from 1 to 4 is where it is decreasing in terms of those x values, or I can say x is an element of 1 to 4. Either way, both answers are perfectly acceptable. So if we apply a bit of this thinking in these questions here, find x such that f dash x is greater than 0. This is sort of related to the idea of strictly increasing or decreasing, but not quite, because what we're looking at here is specifically the gradient, so where the gradient is greater than 0. And, well, assuming that this graph goes off to negative infinity that direction and positive infinity in that direction, then, the gradient is positive for all the sections, so from negative infinity to 1. So I could say that is where we have x such that x is less than 1. And there's another place that's happening, so I'm going to use the union. That's happening from 4 off to infinity. So I can say x such that x is greater than 4. Another way of writing this would be negative infinity to 1 union 4 to positive infinity. Okay, and so in doing the second one, find x such that f dash x is less than 0, so where the gradient is negative. That's happening between these two turning points. Okay, that's where the graph is negative, where the gradient is negative, I should say. So what that means then is we can say x such that 1 is less than x is less than 4. So basically saying that x is between 1 and 4. Or we could just say the interval, I should probably write x as an element of, and that's just 1 to 4. Not inclusive again, because at those turning points it has a gradient of 0. And so that really helps us to answer the last part, find x such that f dash x is equal to 0. So that's actually just happening at the turning points. And just a second. Right, sorry about that. So all I'm going to do here is I'm going to write it using the set notation, so I'm using set brackets here, and it's just a list of the x coordinates where that's happening, and so that is at 1, and it's also at 4, and I can close off my set brackets there, and we are done. Anyway, see you next time.